A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, today my topic is the gametogenesis. Gametogenesis. Gametogenesis is the process by which male and female sex cells Gametogenesis is the process by which male and female sex cells or gametes or gametes, that is sperms or ova, sperms and ova are formed respectively, are formed respectively in the male and female gonads. In the male and female gonads. Now there is the spermatogenesis. What is spermatogenesis? We can write down now spermatogenesis. What is spermatogenesis? You know that it is a process of formation of sperms. It is the process of formation of sperms is called spermatogenesis. It's called spermatogenesis. You see that it occurs in the symphysis tubulus of the testes. It occurs in the seminiferous tubulus of the testes, and you see that the seminiferous tubulus are lined by germinal epithelium. These seminiferous tubulus are lined by these seminiferous tubulus are lined by germinal epithelium. These are lined by germinal epithelium, and the germinal epithelium consists largely of cuboidal primary. The germinal epithelium consists of cuboidal primary or cuboidal primary or cuboidal primary or primordial germ cells. Primordial germ cells. We know that the spermatogenesis, it contain in spermatogenesis the seminiferous tubulus also contain the primordial germ cells as well as the tall somatic cells. It contains tall somatic cells. We can say that these seminiferous tubulus, they are lined by germinal epithelium, and the germinal epithelium consists of primordial germ cells as well as tall somatic cells. We see that this is the primordial germ cell. This is the primordial cell. Firstly, the cell goes mitosis first. It goes mitosis first, and it divides into two cells. This is dividing into two cells. We know that this haploid, it contains 46 number of chromosomes. When it divides, the number of the chromosomes remains the same. So this is also a diploid. It contains 46 chromosomes. This is the meiosis first, and after that it goes meiosis second. It goes meiosis second, this is the meiosis, this is the mitosis second, this is the this is the mitosis first, and this is the mitosis second, where the number of the chromosomes remain the same in all of these cells formed. Now there are 4 cells which are totally haploid. 4 cells are here formed, and we are called them spermatogonium. We are called them spermatogonium. After that, one of these 4 cells, one cell contains food. There one cell enlarges in size. This one cell enlarges in size, and accumulates food material, and accumulates more and more food material, so that this cell divides into 2 daughter cells, and we say that there is meiosis first. When it divides into 2 daughter cells, the number of chromosomes divided into, it was 46. Now in meiosis first, the number of chromosomes became now, each of the cell became now haploid, and number of chromosomes are 23 and 23. After that, there is a second meiosis second. There is a meiosis second, and this cell also divides into 2 cells, and this cell also divides into 2 cells, resulting 4 spermatogenesis. We can say that there is formation of 4 spermatogenesis, formation of formation of 4 spermatogenesis, and we can say these are now spermatozoa. We can say these are now spermatozoa. This is the process of spermatogenesis. Now there are the 3 phases. One is this called the multiplication phase, and second phase is called the growth phase, and third phase is called the maturation phase. Now we can see here, I told you that there are the 3 phases. One is the multiplication phase, and second is the growth phase, and third is the maturation phase. First is the multiplication phase. We see that asexual majority, the undifferentiated cells divide several times. They divide, the undifferentiated cells divide several times. They divide several times to produce a large number of spermatogonia. To produce a large number of spermatogonia. And we see that there's in Greek spermia means seeds and gona means generation. Now we see that spermatogonia, they are diploid and are 2 types. Spermatogonia are diploid and are 2 types. There are 2 types, type A spermatogonia and type B spermatogonia. Type A spermatogonia and type B spermatogonia. These are 2 types. If we say the type A spermatogonia should at the stem cells. It should as the type A spermatogonia should as type A spermatogonia, it serves as the stem cells. As stem cells, we divide to form additional spermatogonia, which divide to form additional spermatogonia. This type A spermatogonia and type B spermatogonia are the precursors of sperms, and type B spermatogonia are precursors, CUS or suckers of, they are the precursors of gametes. You can say that type B spermatogonia, they are the precursors of spermus, precursors of spermus. And now there is the growth phase. The second phase here, it is now the growth phase. What we say, what is growth phase? We see that the growth phase, what it happens in the growth phase, there is type B spermatogonia actually grows. In growth phase, each type B spermatogonia actually grows. Each type B spermatogonia actually grows. It actually grows, and after that to a large spermatocyte. It actually grows to a large spermatocyte. So in growth phase, we should note that this type B spermatogonia actually grows to a large spermatocyte, by obtaining a nourishment from the nursing cells. By obtaining a nourishment from the nervous cells, which are also called Sertoli cells. These are also called Sertoli cells. Their function is they give nourishment to the spermus. So in the growth phase, we see that each type B spermatogonia actually grows to form a large spermatocyte to obtain a nourishment from the nursing cells. Number 3 is the one maturing phase. What is the maturing phase? Maturation phase. If we see in a maturing phase, each primary spermatocyte undergoes 2 successive divisions. In maturation phase, each primary spermatocyte undergoes 2 successive divisions. Each primary spermatocyte undergoes 2 successive. Each primary spermatocyte undergoes 2 successive divisions called maturation phase. Maturation phase. Now we can say in a maturation phase, each primary spermatocyte which is formed during the growth phase, it undergoes the 2 successive divisions, which is now called the maturation phase, and in that phase, the first maturation phase division is reduced. It's a reductional or meiotic. The first maturation phase is reductional. It is reductional. That it is mitotic is reductional. REDUCT reductional. That is mitotic. MEIOTIC mitotic. That is one cell divides into two haploid daughter cells. In this maturation phase, we can say that hence here the primary spermatocyte divides into two haploid daughter cells. Here we can say here the primary spermatocyte it divides metatically into two haploid daughter cells. Divides into two daughter cells, but mitotically. We see that there is now, firstly, in the multiple phase, there is the mitosis, and the growth phase, there is also the mitosis, and in the third phase, maturity phase, there is this diploid cell now divides into the two daughter haploid cells, and these are called now secondary spermatocytes. Now these are called secondary spermatocytes. These are now secondary spermatocytes here, and we see that both secondary spermatocytes now undergo second maturation division. After that, these two formed. After that, these two formed haploid daughter cells undergo maturation phase, and when they undergo maturation phase, we can say that there is a maturation division which is an ordinary, and there forms four haploid spermatids. Goldman, these two daughter cells divides mitotically. These forms the four haploid spermatids, which are called spermatozoa, and the process called the spermatogenesis, and the process is called the spermatogenesis. Genesis. Thanks.